Hello there. Welcome to maptimeLEX, the December edition. I am Boyd, and I'm here with
Rich Donahue.
And we're going to be playing with Mapbox. And I'm going to go ahead and post this channel in our Slack. And we want to give a big shout out to all the folks at New Maps Plus. And okay, so we have sent out a link to our Slack channel, and hopefully some of the technological issues that we're dealing with on our end are not being cast out or televised out to the world for you guys. But if so, just let us know. We're up on Slack. And so with that, I think we'll go ahead and drop into some of the unique and fun things that we can do with Mapbox. And I'll just turn it over to you, Rich.
Good, thanks. Thanks, Boyd. Both Boyd and I have been playing with Mapbox a little bit more, integrating some of these tools and mapping techniques into our classes. And we thought we would take this map time to use that opportunity to share some of these. Again, we have a GitHub repo up here. If you're watching and listening, if you go to github.com, maptimeLEX houses the other repositories for various map time events here in Lexington. And one we have today is called Mapbox Does That, where we've collected some of the writing and thoughts and some of the walkthrough. So this is a two-part session. I'm going to begin, and I'm going to be playing with this idea, what I've called big data stories with Mapbox Studio and Story Map. I'm going to walk us through a process here. The write-up isn't complete in terms of concrete details, but it's the general walkthrough of a process that I've been playing with a little bit this week. So feel free to try to follow along with this, and you can always email us or post issues or something within the repo with questions or something like that. So for my presentation demonstration, I'm going to tease the relationship between two things. One of them is big data, which we all probably know about. Massive amounts of data out there. We're struggling to understand it, to analyze it. We use various tools. Specifically, I think for us lately, using Python and notebooks and kind of visualization tools to kind of get into the big data and understand it and see it at that level, more of an analytical approach. But I want to kind of try to move past that a little bit in just a proof of concept way and bring that into another part of mapping, which is storytelling, which tends to be focused on specific details to guide the user through a very specific presentation of known geographic events and features. So that's what this kind of walkthrough is going to be about. I'm going to gloss over a lot of the specific details. Those of you in my current Map 675 class for New Maps Plus have already kind of walked through all of this, but basically you need to create a Mapbox account. If you haven't already, if you want to do this kind of stuff, you'll need to create and access some public access tokens as well to get in there. We're going to be focusing on three different elements of data in Mapbox's ecosystem. These are their definitions. The data set, we're familiar with this. This is an editable collection of GeoJSON features. This is data and data sets as we normally conceive of them, often in shapefile format, possibly in various raster formats as well. We're then going to take a look at what Mapbox refers to as a tile set. This is a vector tile set. There's a specific file format known as MB tiles. And this basically is a newer way of encoding the geographic information that can be contained within a data set. Finally, there's what's known as a map style, a Mapbox style. This is particular to Mapbox, and there's a style spec that they have. And this is basically a document that takes the vector tile sets and tells an interface or a browser how to display those. So we're going to play with these three things and walk through Mapbox Studio. The basic workflow. Mapbox Studio. The basic workflow. Mapbox Studio. A data set into a tile set and into a style. And so I'm going to first start us off by walking us through a very simple process of doing that. So I picked a data set here. Oops. I'm going to do new tabs for this. So here I found a data set by the transportation.gov, U.S. Department of Transportation, an interesting data set on dams across the United States. So first thing I'm going to do, again, I might move a little quickly here and gloss over some things, but this is, again, more for demonstration process than like a real guided tutorial. So I'm going to do this on my desktop. And I'm going to make a new directory called, already walked through this a few times and used my desired folder directory names. So I'm going to call this Kentucky Water Map Time. And I'm in this directory now, and I'm going to start by downloading this DAMS data set. We can see the APIs do provide some direct access to GeoJSON and some other web mapping services and web feature service. So that's really handy. We can use that to pull that data into QGIS or something like that if we want to, or directly download a GeoJSON. But I'm going to walk us through a more involved process here. I'm going to start by downloading that shape file. And I'm just going to move that into my directory, my KY water map time. Okay, so a couple different things here. I'm using the file directory system to move some files around. Sometimes I'll do that and I'll jump back and forth and I'll move into the terminal, which we'll be using here as well. And I'll be bouncing back to refer to my notes here. So we have this shape file in the directory here. I'm going to go ahead and just unzip that manually here. And we can see we've got some shape files and we have a projection file as well in there, which is nice. And in this case, we can change into that working kind of data directory. One of our favorite tools that we really like to promote here is the Map Shaper library, which has a nice web interface, but also has a command line utility that's very powerful. So if you work in a node environment, you can install Map Shaper and always have that ready in your global environment in your system. And so, for instance, in this case, I can start to do some very basic things like get some basic information about the shapefile that we downloaded. And so here there's a couple important things we need to highlight. This tells me that these data, and we could look at that projection file as well, but we can see that this data is already unprojected in WGS84 coordinate systems. So that's great. That's the format that we're going to want our GeoJSON to be when we load it up to Mapbox. You can also see some things like I have 8,000 records here, and there's a number of fields that I can consider with their first values. And in particular, because I'm going to focus on Kentucky, I can see that the state here field has the 2-letter code for the state. So I can make an assumption almost here that the KY is going to be that field that we want to filter for. So my next step here, what I want to do is I want to take this shape file and I want to convert it into GeoJSON. And I want to filter out just the dams that are in Kentucky. And we can do some other things as well. So here's a single command. I won't write it out for you because it's pasted in here right now. A single command using Map Shaper, though, that we're going to issue here. So Map Shaper says this is the incoming file, this dam shape. We want to filter it by this expression here. And this is going to say if the index of the state is KY, if it's greater than -0, that is to say if the index is KY, keep this feature. We can furthermore filter some fields that we want. As we saw, there's a lot in here that we don't necessarily want. Again, this is kind of a made-up mapping scenario, so we don't exactly know what we want, but I'm going to keep a few of them just for fun in here. So filter fields, these are the ones we're going to keep: the city, the county name, the dam name. Max storage is interesting. It's a quantitative measure that we might be able to use. Always keep an eye out for those as mappers. And then the river, the name of the river that the dam is on. As we're converting this and exporting it into GeoJSON format, we can also trim the precision, the coordinate precision, which is very nice. So we can chop that down to 5 or 6 decimal places there, and then output that to a new GeoJSON. So I'm just going to paste this in here and run this command. And we can see that happened very quickly. It retained 209 of the 8,000 plus dams and wrote this out into our directory here. So we have this dams JSON. You can see it's a very small file as well, 44 kilobytes, well under any kind of restrictions for Mapbox. So now I'm going to switch back over to my browser and log into my account with Mapbox Studio. Here I can go to Studio, and within this interface, we see at the top here those 3 data formats specs that I mentioned earlier. We have our data sets, our tile sets, and our styles. So here we're going to move from data sets, tile sets to styles. So I can select the data sets, and I'm going to create a new data set. I'm going to upload this, so we can simply drag or drop. These windows out of the way. And I will mention too, we're doing this kind of manually through this web interface, the Mapbox Studio. There's also really cool tools out there that are worth exploring. Different command line tools like this client for Python allows you to kind of issue very quick commands from your terminal if you have a data set that you want immediately pushed up to Mapbox Studio. It also has some other, can retrieve some good information about geocoding or directions or stuff like this. And there's also this upload API that Mapbox supports. So there's different ways to get data up into Mapbox Studio. There are also limitations in terms of the data that you can load through the web interface versus some of these other client solutions. So if you end up with a data set that's too big to upload through the web interface, and it'll let you know that as you try, there are other methods to do that we won't in this session. Nonetheless, got this small data set, dams. I'm going to confirm that. I tested with a different name of a data set, so I'm just going to go call this KY dams. Create the new data set. So the web interface will upload that, tells me it's complete, and now it allows me to start editing. What this does is it puts me into this kind of limbo editing stage here where I can actually go in here and I could change some of these. I could add or delete some. You can draw some other kind of features if you wanted to. Typically, I think we would get most of our data processing done on our end before we would upload to this point. So I'm just going to go ahead and export. And what this does gives me 2 options. I can export this to an already created and connected tile set, or I can export to a new tile set. And this is what I want to do now. So I'm creating a new tile set. We're moving from the data set stage to the tile set stage. Mapbox Studio tells us it's processing. This is a very computationally intense process of taking the GeoJSON data and converting that over to the MB tiles format, which supports these tile sets within Mapbox Studio. So this will crank along for a little bit. This is also the reason why Mapbox has certain limitations on what you can upload. It has less to do with upload bandwidth or anything like that. It actually has to do with the processing power and the computational power it takes to make these kind of conversions. Pretty sure Mapbox makes use of a lot of Amazon's servers for this kind of stuff, and that does come with a cost. So that's part of that explanation. So it says it's succeeded now, and this will take me to this tile set, which sits by itself here. There are ways that we can use the tile set ID as developers within a web document when we make a web map. Again, I'm not covering that right now. But we can notice the zoom extent here from 0 and to 10. which is something to consider, and we may need to adjust that later if we wanted to. So again, to recap where we are now, we've uploaded the data set here first, this GeoJSON, and then we have converted that into a tile set here, KY dams. The next step now is to create a new style. And so I'm going to hit new style here. Mapbox offers us some templates that we can use. These are our fully loaded OSM derived styles, which contain many, many layers in there. It's the kind of the basic maps that we come to know and love and recognize and see, and very high-end kind of cleaning up of OSM data by Mapbox. So they're very nice to pull in. You often want to spend some time deselecting or hiding the layers that you don't necessarily need for your map and customizing that style yourself. For this though, I'm just going to create a blank with no other layers in there so we can get a better sense of how Mapbox Studio is working and how these tile sets become layers within the style. So now I am in the style editing window, and there is a background here, which I can adjust as well. And just going to give myself a dark background there. But what I really want to do here is add a new layer. And so I click new layer, and the interface will begin to load all of the potential data sources. And in this sense, it's referring to these tile sets that we've created. So here's the default Mapbox ones. They're still in there. We can still add those to the style if we wanted to, if we made a mistake and chose blank earlier and didn't mean to. But I'm going to come down here and select our dams. Sometimes it'll pop these open, and it'll be kind of hard to see them or find them. And you can always kind of come up here and toss in some quick satellite imagery. If it loads, well, to get your bearings, but we can see our data right now. So I'm going to go ahead and accept that. They've come in as just small default point symbols here. Now, Kentucky Dams, I can do some styling here. I can change the color. So maybe we want to choose something bluish for water, something like this. Again, these aren't permanent. We can always go in and change them later. So there I've changed the color. The default radius is 5. I might change that to 3. And what we can also do, there's some powerful styling functions within Mapbox Studio here. So we can use quantitative data to style it across a data range. And this is why I retained that max storage number earlier from the dams. And so here I can say, all right, well, we're going to start with our smallest one is going to be 3. And then, so this is referred to as a stop. You can create stops along with this data range. And we can see that the flow, it's kind of calculated. It goes from 0 to 5.6 million, not even sure what that is, cubic volume of water in these dams. So I'm going to add another stop, and I'm going to make it the max. Be a way to click this, just take it to the max. All right, probably a way to get that to click directly to max without it going to this error. Okay, that's good. And then for the max, I'm going to say, let's make it like 20 or something. Okay, so we can see that, and then we can see there's a rate of change that we can also do. So this is a linear rate of change from our smallest one, which is going to be 3 pixels, to our largest one, which is 20. So in the sense, we've created a kind of graduated symbol map already in Studio with these data. Okay, so we could keep styling like this, play with this, but I'm going to call this good for now. I'm going to go ahead and publish this. Now, publishing gives us a couple options. Once it's published, you can see it's not public yet. I can make it public, and that's fine. If we want to share the style, allow other people to do it, and I think possibly if you want to use it as a developer within a web app, it may need to be public. We'll find that out in a little bit. You can also just share that style by itself. So you could, this is Sans web page or anything like this being read directly off Mapbox's servers. So we've got this very simple tiled base map here that we've created in Studio. All right. So that was a very small data set. Now what I want to do is walk us through a process we might need to do if we want to add a different kind of data set, a bigger one to this. So here I was looking at the Fish and Wildlife Service and their data, and they have a download by state option. So I went here and going to download the Kentucky shapefile again. And I can see that this shapefile is coming down in 347 megabytes. So a lot more data. And basically start to follow that same process we did earlier with the other data set.
So, hey, Rich, do we get 50 gigs is the max storage on Mapbox?
I think so. Yeah,
that's
just quite a bit.
Yeah, quite a bit.
Yeah. Yeah, they've expanded their thresholds quite a lot lately. Okay, so again, I'm just going to pull this into my working directory over here. Just rename this. Okay. So this is my working directory in here. There was our dams. I can get rid of that file even. Okay, so now we have quite a few files in here. We're not going to use these all. There's just a basic Kentucky outline, and there's some historic stuff. We're going to focus on the Kentucky wetlands shapefile here, which is quite big, 685 megabytes. So again, I can go back and probably change into this directory and use MapShaper to interrogate these. Okay. Use this info. This is, again, similar to like a Google info if you use the OGR Google command. And again, this is telling me some information that I need to know for this process right now. Importantly, this particular data set is projected into coordinates. So we're going to have to make sure we convert this to WGS84. And we can see it has some attribute data, not too interested in shape area or shape length. But there could be a couple other interesting ones to keep here. Probably the type of the wetland, something like this. And again, if we had more time, I would probably pull this either into QGIS and look at these attribute fields or a Jupyter notebook to get a sense of how many of the features fall under various attribute categories and that kind of thing. But in this case, we'll keep moving along. Okay. So again, here's another MapShaper command I'm going to use. MapShaper will pull in the source file. And in this case, because we're using the shapefile and because it does have a projection file, a proj file associated with it, MapShaper knows what it's converting it from. If we were doing this with a GeoJSON that didn't have the proj file, or this proj file was missing from the shapefile, we would also have to include that in the MapShaper command. We'd have to tell MapShaper what it's converting from and where we're going to. In this case, though, it's very handy. There's even a short alias. We don't even have to use the WPGS code. I can use this WGS84, and I can filter some fields as well. I'm just going to keep that one field for this. Again, chop down the precision, convert it to a GeoJSON, and name it this Kentucky wetlands. So go back here. It's a command, and this will take a little while longer. It's a lot of data to crank through, do the coordinate transformation.
So that precision value, is that the number of decimal places?
Yes. 1, 2, 3, 4. I think that's 5.
5.
We have to look. Yeah.
It's 5.
Which I think is reasonable for something like this, right?
Yeah, I think the GeoJSON, the specification might be 6 decimal places, because the precision, I mean, you get pretty accurate at 6 decimal places.
Yeah.
So
6 might be a good default then. Okay, so it cranked through and it wrote out this Kentucky wetlands JSON file. Which I can see here in the file browser is 675 megabytes large. So this is going to be too large for us to go back. So if I go back into my Mapbox Studio account, before we uploaded this as a data set, but this is not going to work now, because upload larger than 5 megabytes here for a GeoJSON requires us to get into this datasets API, which is something good and something we can cover at a later date. It's a little in depth, and this actually does make use of Amazon's servers, and so you have to kind of set up a little bit of an account there and walk through that, but it's worth it. And then there, I think you get, does it say what the limits are? Oh, sorry, I don't have the exact limits pulled up right now. Anyway, so we're going to go a different route. Instead of uploading a data set, we're going to upload directly as a tile set. And to do this, we're going to make use of another tool that Mapbox has given us called Tippecanoe. The last I checked, it was not available on Windows. I think it's only available on a Mac. So that's that. But basically, Tippecanoe is another command line utility here, a client that can make these kind of conversions for us. Now, this is something that I've played around with a little bit, but there are lots of little parameters here you can tweak depending on the type of your data. It has several examples here where it kind of walks you through things you might want to do for different kinds of data sets, clustered points, large point data sets, non-contiguous polygons, this kind of thing. And I think that it would take a lot of trial and error to kind of get a sense of the accuracy of the tile set that comes out of this process. You might need to do a few more depending on your map task and things like that. In this case, I'm just going to, I kind of played around with this, and I've decided Tippecanoe is going to set the high zoom level at 12 here and the low zoom level at 6. I just kind of arrived at that looking at the state of Kentucky and the various zoom levels in these mapping applications. So we're going to output that to a Kentucky wetlands MB tiles. And then this parameter is often used, drop densest as needed, and output this to a KY wetlands JSON. So I guess, there's one caveat we could have here. At this stage in the process, Tippecanoe, we're definitely going to be possibly losing data. We're generalizing data quite a bit. We're simplifying data. So this is very different than a GIS process that might use some exactitude of these stream data for some reason, like determining where or exactly a well might be close to it, or a toxic site next to a stream or something like this. We're definitely getting to the front end representation part of the mapping stuff. So we're sacrificing accuracy accuracy here for the ability to take a giant data set and show that and use that within a web map. So that's a trade-off we always need to consider. So I will go ahead and return to my terminal. And wait, did I? Wait, sorry. Just want to make sure. Okay, sorry. So I put this as KY wetlands. Yep. Okay. So we'll run that one. This will crank along for a while. There's other parameters you can include as well to kind of give you more information as it's going through. Providing this output file with some information, attribute information like this. You can also target specific layers. Because we're dealing with a GeoJSON at this point and not a shapefile, we can have multiple different geometries and different layers within GeoJSON. So you could target, if you had a big GeoJSON that had all your lines and your polygons and your points in it, maybe you just want to do something with one of those layers. So it offers that. It's kind of an interesting option to consider there. Extend zoom if still dropping. So if it is cranking along and it's dropping too many of your data points and you're losing data, then maybe it would increase the max zoom. Or again, the zoom levels, that's all going to be dependent on how big you want this file to end up and your mapping needs for zoom levels.
Yeah, Rich. So I guess the topology, if it's included in it, probably gets crushed, huh? Like if you had any kind of network, because GIS, they build a lot of the overlap and that kind of stuff, and how it's connected. This probably just crushes it, huh?
I feel it does. Yeah, I want to play with these tile sets more, but
can you? So my first encounter with this format was back with TileMill.
Yes.
And it doesn't output, so it's not a raster format. I mean, there's no raster. I mean, you can't include raster in this format because isn't the MB tiles format? Isn't it? It's a SQLite, I believe, right?
So, yeah. Yeah, we could dive into the spec a little bit. Okay. All right. So what did this output for me? Okay. So here we can see now we've taken this KY wetlands GeoJSON, much bigger than the shapefile, obviously, and we've converted that into this MB tiles file, which is 69.1 megabytes. So the upload limit for the tile sets is actually much larger than the GeoJSON. Yeah. And I will note too, we've kind of walked through that data set step, which isn't always necessary. It was more to kind of demonstrate this flow. But this shows us you are able to actually upload GeoJSON or shape files, zip shape files directly to, and this will convert that shape file into a tile set as well. Again, as long as that shape file is WGS84. So in this case, I'm going to go ahead and try uploading this 60, well, it reads as 66 megabytes MB tiles. Go ahead and confirm that. Again, we've got a little time here for some Q&A. This will upload, and then this will also be processing that and getting that ready. And since we've already done the processing into MB tiles at the local level, this should be a little faster at this point. But
So imagine back in the day with DSL connections. You're not going to be uploading 60 megs, with the 500K upload. For a long time, I only had like a 2 megabyte upload speed.
yeah,
That was crazy. You have to come on campus, and use the network here.
do all your uploading.
Yeah. But apparently there's a couple counties in Eastern Kentucky that are being fully wired with fiber.
I read that.
Every structure.
Fastest internet in the country.
Yeah. So, imagine we're sitting out here in the country, beautiful surroundings, and we're doing all this as opposed to being in Lexington, which is cool. But
yeah,
if you're out in the country, you could perhaps enjoy those amenities.
Okay. So it's successfully uploaded this tile set. It's now available for me in my tile sets here. And what I'm going to do is go back to that style that we created. And I realized I didn't name it. We called it blank, but I could call this like Kentucky water or something like this. Okay. So we still have our style with our 2 layers. We have the background layer and the KY dams. I can go ahead and add this new one that we created for the wetlands. And we can now go ahead and do some very basic styling. I won't spend much time on this. Pick an appropriate blue of some kind. Okay. All right. There we are. Yeah, I might play with those colors a little bit more with more time, but nonetheless, we could go in here too. We said, earlier I showed you we can style across a data range with a quantitative measure. We can also style with different data categorical attributes. So we can see that the types of different polygons here within this data set, and we have lakes, freshwater ponds, wetlands. So we could and river lines. So we could give these different colors, different styles based off of that data condition. But for now, I'm just going to accept this as our style. And to now update this and make use of this, I need to republish it. So it kind of shows you what happened before and what the current status is. Oh, one thing I can also do is try to change the layers of these a little bit. So I might want those dams to be on top of the wetlands or something like this. All right, I'm going to go ahead and publish that. Okay. And now this is available again for preview and for development. Okay, so I guess a question for us. The next step with all this, what I was going to do is bring this into a web environment here, and we're going to basically build something kind of like this using a template by Mapbox called Storytelling, I believe. Making use of this template. which is a fun template. Al, should I walk us through this process? I'm afraid it's going to take like 20, 30 minutes. I don't know if we want to like kind of basically just show the overview here and not actually go through it, and then we can flip over to you.
Yeah, I think we.
Okay, let me do that. But basically, my next steps were cloning this down, and then basically this repo has a couple files in here. You can either build this within a React environment if you know how to do that, or there's just plain vanilla S here, JS. And so what this does is basically this file here, this index file, allows you to plug in the style that you created. So you would go back here to your styles. You have the style URL. So you would copy that and plug that into the HTML file. So this is kind of, it's a fun, very accessible template for doing this kind of story map, scrolly telling. And so essentially there is this index file, which you don't mess around too much with the JavaScript unless you want to start to hack it and change that a little bit. You might change some styles up here, but really what you spend most of your time doing is in this configuration file where you're going to plug in the style URL that you created here, your Mapbox access token, and then there's certain parameters you can change, like if you want it to be a light or a dark theme, if you want the alignment of things to be on the left or the right. And then you have a series of chapters, which basically involve a unique ID for each one. And then there's ways you can just start to plug in content and copy. So a title for each of these kind of chapters, you can add images, and then there's lots of text. You can include links or whatever you want in these. And a location and various elements for zoom, pitch, and bearing. I'll just demo this really quickly because it's pretty neat. Let's see. So developing now on just a local level, a local host. This was this kind of similar tile set I made. So the idea here is that each chapter goes, and each chapter has some kind of content that kind of refers to where you're looking at the map. And with each one, you can then zoom to a new location. So you spend time in this configuration file, picking a new location and zoom, and you can also change the pitch and the bearing as well. This is something that vector tile sets are good at, is not just being in that kind of planar XY coordinate space, but they can actually change this pitch and this bearing as well. So you can begin to think about taking a data set and having various chapters and having highlights. What the template also provides for is an on chapter enter and an on chapter exit. So as you enter one, you could have new layers kind of turn on and off to highlight certain features or something like this. So a really exciting little tool here. It also has this kind of fun helper file they included with the template, which allows you, so there's the full kind of data set. And then, if you are going to tell a story and you're like, okay, I want to be here and I want this kind of a view in this one, and then you can just like look at this information and plug that directly back into your configuration file for these chapters. So a fairly quick way to kind of run through various elements of a story to kind of pull that together. And with that, yeah, I think it's probably a good place to wrap up without dragging us through all the details of that. Yeah.
Some Mapbox awesomeness right there.
Okay, cool.
Good job.
Well, thanks, Boyd. All right, and so with that, I think we'll turn it over to Boyd, who's going to show us some other cool tricks with Mapbox.
Yeah, I think we need to switch some power and switch projector. Yeah, so wasn't Tippecanoe, wasn't it developed by Mapbox too?
Yes.
So they've got the data crunching, they've got the hosting, now they've got the presentation side. You can put on your own domain. Okay, hey, let's see here. I got some folks on, and welcome. And let's continue talking about Mapbox. And you might have noticed today, at least I did, we have this new components tab in Mapbox Studio. And what I wanted to do was simply do 3D or 2.5D. Is this real 3D? 2.5D? But anyway, the idea is to bring in buildings with height info that we can then extrude in Mapbox Studio. So I thought that was pretty slick and pretty nice to add to the map. But if you look at the components tab, we now have buildings available in Mapbox Studio by default, and you can enable 3D buildings, and we can compare that to the buildings that I created, and then you can also create. So if you zoom in, let's disable my buildings. And so they're slightly transparent by default, their buildings. So that's what they have. And so not really, don't have everything, but I have enough to give a sense of a city, urban area. Let's enable. And so here are the extruded buildings you can make with the appropriate data. Now, of course, you can get these, you first have to start with the building footprint. And of course, you might have heard about the Bing Microsoft footprint for the entire US. Pretty handy, you can pull that down. In Fayette County, we have data sets that include the impervious layer, which are footprints. And so this is available for Lexington. Of course, OSM has building footprint. So you start with that. You start with a building footprint. And if you go up to the repository, you can download the data I have for this quick presentation. And so what I have is two layers, and I'm going to bring in QGIS now, two important layers. And these are the digital elevation model, that is bare earth ground, pretty typical raster data set. And it's commonly available through USGS web pages. And the second layer I have is the digital surface model. And that is all the above ground features. And what we have is now the tops of everything in Lexington. And so I won't go into how this is made, but this is a common derivative of point cloud of LiDAR data. And there are tools on Windows that you can export out the digital surface model. But what we want to do is find the difference between the digital surface model, which is the top of everything, to the ground, to the elevation of the ground. And that will give us the height of above ground features. And so what we do is we have our two layers in, we can jump into raster calculator. And so we take the digital surface model and we subtract the elevation of the ground. So we have the elevation of of above ground features, and we're subtracting the elevation of the ground. Let's give it an output.
I'm sorry, where did the attribute for the above ground elevation come from?
So those are points. So that's a point cloud derivative.
Okay.
And so we have point clouds available for the entire state of Kentucky, and I just generated a above ground raster on Windows. Well, actually, I used ArcGIS, and there's tools in Windows QGIS that you can use. It's LAS tools, but I haven't loaded those guys up. Maybe that could be a topic for another map time.
And again, forgive my ignorance a little bit, but what is a point cloud?
So that's a massively sampled 3D space. And so you get
Okay.
points in, with X, Y, Z and other attributes
Yeah.
that it's sampled by an active sensor, a laser scanner, basically, that's
Okay.
flown by an airplane.
It's a plane derived. Okay.
Yeah, so it's a remote sensing data set.
Yeah.
And so
Okay.
I'll call this guy Z range, Lex, TIFF. And so let's crank this guy out. So yeah, LiDAR is becoming pretty huge, at least in my orbit. And I'm just trying to figure out more open source ways to work with it, because the point cloud, it's very proprietary in some ways, or at least the tools that are used to make it and edit them. You know, of course, ArcGIS Pro is not free. But now we have so turn these guys off. So this is now the range, the Z range of ground to top. And so we have something that's 1,400 feet above the ground and something that's below ground. And let's go ahead and just create a quick hill shade of that to get a sense of what we're working with here. Let's see, direction. That's from the last. Let's see, range hillshade. And so this will be, I just use all the default tools. And we will create something that's textured that gives a sense of, so it's a hillshade, but now we're using all the above ground features. So you can recognize there's Ruparina, we've got, these are the sky tubes. And so you can recognize that. But we're missing the ground features, right? So we only see the above ground. There's holes there, we don't see those, or depressions, I should say, of course. Okay, anyway, so now we drop in buildings, and the idea is to do zonal statistics from the raster layer to the polygon layer. So let me get a little bit of transparency here. And there's some issues we have to face first, and so the data set, the building data set, is connected. So it's just this in many vector layers that represent building footprints, we have connected buildings. So it's all merged into one polygon. And let me select. So what you'll have to do, and so this was one polygon at one time until I went in and just edited the polygon. So for instance, you could come in and let's select this feature. Okay, where'd my little edit? Yeah, it's the some of the tools are missing because the monitor size is a little smaller, but the point is that you can edit these polygons to split them up so that whenever you capture the elevation or the height of the building, you get more variation in the building output. So let's take a look at this tool to get an idea what's happening. And so if you go to the processing tab and you do a search for zonal statistics, and the idea is that it goes polygon by polygon, that's considered a zone. And it will take statistics of the raster that it intersects, the raster cell values that it intersects. So we do common statisticals or summary statistical stuff like the average cell value. By default, it does count, sum, mean. We can add median, minimum and maximum cell value. We would want the maximum cell value to get the tallest building, and then range. And so these will be columns added to our vector layer. Let's hit OK. Let's get the raster. Let's see. Raster band. And this is the output column prefix. You can, I'm going to put just BH there for building height. And we'll run this. Am I missing something? So this is, I just installed a new version of QGIS, and it's jumping back. Well, this tool, maybe I need to relaunch Q. It's one of these circumstances, it seems. I'll just jump ahead here. So this is a tool you want to summarize the cell values of cells that intersect any polygon layer you want. So the output, and I did run it, and I can show you, is so you get something like this on the output. You get a columns with the elevation or the statistics for what that polygon intersected. So we got mean, height, median, minimum, and maximum. Okay, so one thing you'll have to do if you want to make a good looking data set is we have some gotchas here. And what you do is you sort, after you get an output, you can sort by height. And then we want to jump and find that height in our data. So there, you might recognize that building. We zoom out. And so that's the big blue building downtown. So that's the highest building in Lexington, and that's what we find here. But I've already edited this layer to remove things like, so we sometimes have anomalies in our data. Birds sometimes will be caught, and there'll be single pixels you'll find, and you can just recalculate or change that elevation in your attribute table. So at this point, once you go through and check and make sure that, let's just try another one here. Zoom to that feature, and what building's that? Well, it's the one downtown. That's the Central Bank building. And just do one more. But if ever you come to something that has just one pixel and you have to turn off, you can get the Z range, you'll see a very bright pixel like over here, for instance. So that is likely, it's noise. It's noise in the data, and it wasn't filtered in the original data set. So it comes across in any kind of derivative data you make. If that pixel intersects one of your buildings, you'll have to recalculate manually that building height. Like that pixel there intersects this, and so it'll increase the maximum elevation as well as the mean and median. Okay, so once we get something that we like, it's pretty straightforward at this point. I don't think I'm skipping anything. We want to export, and we save features as your favorite data format that you want to upload into Mapbox. And I just did the shapefile and keep any of these you would like. And after I exported, of course, the WGS84, so this is the actual file that zipped up. So you can shapefile out, you zip it up, and there it is. You upload it into Mapbox here. As Rich just pointed out, you go to tile sets and you can simply upload it. And I won't do that now, but you can see here that there's the building footprints. And I also exported as a geotiff that hillshade. And so that adds an extra kind of dimension of real reality in our map. And so let's go back to the tiles.
Again, it's nice there that you can upload a 16 megabyte shapefile zip directly as a tile set here.
Yeah.
It's exactly. Much bigger than the 5 megabyte cap on the GeoJSON for the data set.
And, you know, and working with, I mean, it's pretty handy for smaller stuff, that data set tab, but I think if you're going to kind of editing of something this big, you probably want to do it in a GIS.
Mm-hmm.
And so what I have here is I've created a monochrome style, and like I said, they just introduced these buildings for the, I guess, from where I've checked, everywhere there are buildings. Let me go turn those guys off. So when you add the data, so probably should do that first. So we add a tile set, and if you select the tile set, all you need to do is change the type. We want to change it to fill extrusion. Select that, and you add it, and you start styling. And a couple things you want to do if you're working in feet, you have to know your unit, of course. We need to change that, convert it to meters. And yeah, so we just apply we can pick the attribute that we want in the fill height formula. And so I'm doing max, converting it to meters. And another thing I like to do is we can adjust the opacity. Kind of makes an interesting, I don't know how interesting it is though. But I guess if you were zoomed in, you can see through it. Okay, so I'm going to leave it 100% opaque there. And I want to bring in one other layer. I've added, in the same way, I've added this guy. This is that raster layer for hill shading of the above ground features. Mm-hmm. And I've changed its opacity because if you so what I'm looking for is actually the tree tops. Like if you go into a more suburban, you know, we can't extrude trees because they're not all the same height. You know, it would be interesting to see if you could somehow chop up all the trees into individual, much smaller polygons and extrude those, make them green. Because
thinking about like a dome or two, like the old courthouse, what does that look like?
It's all flat top.
Yeah.
And so there is. So you just get the outline.
Right. Yeah.
But so that's another, I think this is, especially if you zoom out, you get a sense of the city.
Yeah.
And so this is all inside New Circle. Although this is one thing I've noticed recently is that they switch on and off depending upon zoom. And I have no control over zoom and opacity or anything. So I don't know. What's happening there, but anyway, so I think
really cool.
I think the next kind of step I want to explore is somehow better showing the canopy top. Because if you mix canopy with building height and in this kind of cool three-dimensional, or where you can change the pitch, and it might provide some kind of cool realism, especially when you start adding stories. Imagine if you take, that storytelling library that Mapbox has, and we can just zoom and spin these guys. I mean, you got historic tours, you've got maybe canopy.
I think it'd be fun to make it. Yeah, here's a tour of Lexington, zooming around the city and showing various places. Yeah.
And so we just kind of, I'm extruding the height, obviously, but we can also color the building based on its type. And so if we had a couple dozen buildings that we wanted to showcase, well, we just create an attribute that we can then style or change in our map here.
Yeah.
So all the old buildings, like if we had attributes for the age of buildings, that'd be pretty cool.
Right.
National historic properties.
Yep. One thing I'm thinking of is maybe back in the processing before you get it in studio, I imagine. But if you took an ortho photo and basically like overlaid that over the building footprints and just kept the ortho photo for each building footprint, and then you extruded that. Does that make sense? Is that how you would get that kind of like?
So like if you have an aerial image.
Yeah.
And well, so the first thing I think about when I think of aerial imagery is that there's parallax.
Yeah.
And so it does. So buildings that are tall, the taller the building, if the camera's not directly on top of the building, it's going to look. You're going to see the side of it.
Right.
And you see that in the Bing footprints because we're using aerial imagery to create the footprint.
Yeah. Exactly.
And so the LiDAR gives us that. It's directly above the feature when it captures it.
Yeah.
And so.
Well, you would still use the LiDAR for the extrusion. I'm just thinking instead of having just these like plain polygons, right? It could be.
Yeah.
I don't know how that would look, but.
I mean, that's probably. I mean, putting a raster image on the side of this, that is the building itself. That's probably they're probably thinking because Google, they make their 3D model from photogrammetry.
Yeah.
Just planes flying around and photographing off angle. So
yeah.
But this is obviously free unless you get popular, but that's a good thing to have, right? So as long as you're not too popular, just popular enough, you're not going to exceed their API limits.
Yeah, and again, they know about us, and they've said that if that happens, talk to them, and they'll bump up the quotas. So, yeah.
Well, that sounds good. Well, I think that's all I wanted to show.
Yeah. Any questions from our local audience? No. Any from our remote audience? Ryan, Matthew, you still with us?
Yeah, and so I will say that we'll fill out this repo a little more, and I have the screenshots. And I just have to add some of the content, but it's a pretty straightforward process.
Yeah, really cool. I'm gonna try that out.
And Cube with their 2.5D, you can actually extrude inside of that. Can't spin it around because you're just kind of stuck in that. But that's a cool alternative if you want to print the map. Okay, well.
Yeah, great. Well, thanks, Boyd, for organizing the Lex time.
Well, thank you, Rich.
The maptimeLEX this
Yeah,
this term. It's our final one for 2019.
And stay tuned for 2020, where we get 2020 vision and planning the future. And so,
Love it.
And yeah, so
All
thanks
right.
for showing up. We're gonna head out of here.
Yeah. Thanks, everybody. Have
Okay.
a great night and keep mapping.